Okay, so in this video, we're going to look at how moving a function around, transformations. I want to look at how transformations are going to affect the domain and range of a function. And hopefully it's not too bad. I think it's pretty straightforward, but we'll see. So we're given a little bit of information about f of x. It says the domain of f of x is -4 to 9. So that just means that the furthest left that it goes is -4, and the furthest right that it goes is +9. So the furthest left it goes is -4, the furthest right it goes is -9. We don't actually have a definition for this function, like a rule or a graph, but I can make a graph pretty easily. So I'll put a closed dot at -4 because it's a bracket, a closed dot at the 9, and I don't know what it's doing in between here, but I know that it goes from -4 to 9. The question is, what will be the domain of f of x minus 6 plus 2? Now, hopefully this makes sense. If you move something left and right, it's going to change the x values, right? So that means its domain is going to change, because that's what the domain is. It's all the x values that the function takes on. And if you move something up and down, it changes the y values, therefore changing the range. Okay, so this plus 2, the fact that it's moving it 2 units up, 2 up, has no effect on the domain. We can kind of ignore that part. It's not going to play a role in answering this question. But the fact that we are moving this 6 units to the right, that's what subtracting on the inside does. That's the little rule for that. Subtracting on the inside moves it to the right. What this is going to do is it's going to increase our domain. All right. Imagine if we take this made up function that I have and move it 6 units to the right. This -4 is going to get moved to the 2, right? And this 9 is going to get moved to the 15. So moving it 6 right means we add 6 to each endpoint of the domain. Okay, so since our domain was -4 to 9 originally, I'm just going to take each one of these numbers and add 6 to it. And that's going to be my answer. So the -4 becomes a 2, and the 9 becomes a 15. And that is our answer. That's going to be the new domain. Hopefully that makes sense. If we were moving it to the left instead, we would be subtracting from these numbers. Okay. Let's go ahead and we'll do one with the range. The range of f of x is -infinity to 5. What will be the range of this? Now, you don't have to draw a picture, but I know how to draw pictures, so I like doing this. The fact that the range is -infinity to 5 means that it goes down forever, and the highest it ever reaches, the range is the y values, the highest it ever reaches is a 5. So there's 5, and I'll just put a dot here, and I'm going to say it's going to go down forever. Okay, this is not, I don't know exactly what the function looks like, but this has a range of -infinity to 5. Okay, this part, 4 left, we can ignore this part because it doesn't affect our range at all. And the 3 down, okay, since we are moving it down, that is going to affect our range. All right, so if you imagine this whole function just shifted down 3 units, that's going to cause us to subtract 3 from our range. Okay, down 3 means we need to subtract 3 from our range. And that's what I'm going to do. All right, I'm going to subtract 3 from both of these endpoints. Well, -infinity minus 3 is still -infinity, and 5 minus 3 is going to be 2. This is going to be our our new range. All right, if we just take this and shift it down 3 units, it would look something like this instead. Okay. Last one. This last one is going to be a reflection. I want to look at how the reflection is going to change things. F of x is graphed below. What will be the domain of f of negative x plus 4? Okay, so this part, the adding 4, the up by 4, we can ignore that part. That's not going to play any role in our domain. Moving it up and down doesn't change the domain. So forget about that part. We don't need that part. What we're doing here is we are reflecting it across the y-axis. Okay, f of negative x is a reflection across the y-axis. So each of these endpoints are going to get reflected over here. Before I do this, let's state what the domain is. What the old domain is how far left and right it goes. So the old domain is 1 to 5. Right? That's how far left and right it goes. The new domain So if we reflect each of these points over, this would be negative 1 comma 1 now. And then the 5 comma 2 would get reflected over here somewhere. So this would be the reflection across the y-axis. It's not perfect, but anyway. Negative 5 comma 2, negative 1 comma 1. And you can see from the picture what the domain would be. It would be negative 5 to negative 1. That's how far left and right this thing stretches. But if you notice, that's just the opposite of these numbers that are here. And that's what you do for reflections, is you not only change the signs, like you'll add a negative to each one of these, but you'll also swap the order. So it's negative 5 and negative 1. And that's going to be our new domain.